Alright, start recording. Recording. Good, okay. On the bench tonight, we got a Kessler crane controller. This is for professional photography. You can use this to control a camera if you want to go around something or take, panoramic photos or whatever. Anyway, the owner said they accidentally, or there were the wires on the DC cord were cut, and they think they wired it in backwards, and so they blew something on the board because it stopped turning on. I know it runs off of 12 volts and like a 1.4 amps or something like that. So we're going to power it on with my bench supply and see if it does anything. Yeah, it's drawing 112 milliamps, going down to 1.4 volts. I had a look around on this earlier with the thermal camera, and I ordered some parts because I think I found the issue. I just wanted to do a quick video to see if my hunch is correct. If I replace the MOSFET, I think it's a MOSFET, yeah, that's blown. But if we replace that, see if we can get this thing running for the customer. They've been waiting patiently, so we're gonna give it a try and see if we can't fix it. So we're gonna go ahead and pop the cover off, and I can smell a strong electronic smell, like something got hot. And if we prop it like this, right down here, there is a MOSFET, and this MOSFET gets really hot. And also there's a diode here, a big diode. I can show you under the microscope, but that leg is, there's a leg that's cut. Somebody cut it. I don't know why. Don't know if that has anything to do with it or not. We're also going to test that. We'll test that diode, make sure it's good. If not, we'll replace it. Like I said, I already pre-ordered some parts to see if I can figure out the fault. Not saying it will repair it, but we're going to change those first and see what happens. Check for shorts, on that MOSFET before and after. Alright, so there's our board. Awesome. So I'm gonna go ahead and show you under the thermal camera. I'm gonna turn my thermal camera on. Show you what I found. That thing gets really hot. That MOSFET's getting to about 140 degrees or something thereabouts. Somewhere in that ballpark. This diode right here, I'll show you under the microscope. One of the legs is cut. Scope cam. So I don't know if you could see it or not, but right here, right there, that diode is not attached. It's been cut. Before we power it on, let's unplug our DC jack. We'll go to diode mode on our multimeter and we'll test it and see if it's any good or not. See if I can get in here. Open line that way. I think this diode was actually good. It's just got cut for some reason. 0.168. Seems a little low. I got some replacements. We'll go ahead and test the replacements and see what they're reading. Like I said, I did have this open, a preliminary look, because I've had it for about a week now. So I wanted to troubleshoot so I can order stuff I needed to if it was blown, and so I ordered what I got. Open line that way. Nope, so that diode should be good. I wonder if I could solder that. I'm wondering if I can solder that and just solder that leg back together and it should be okay. I'm not sure why they decided to do that, cut that leg. Anyway, let's go to overhead and I'll show you what I found here. I'm going to power it on, my thermal camera. You can see the board is nice and cool right now in this area. Not doing it anymore. Oh, you know what? I don't have the voltage up. You ding dong. I had it at 1.4 volts. Let me put it at 12 volts. Oh, it's working. Whoa. Interesting. You can see that. Whoa, that does not sound good though. It is working. Is it just that diode that's crapped out? What did I do with the manual for this? That's interesting. It wasn't working before. I'm wondering if it has to do with the diode being cut. I hear a weird sound though, so I don't know if there's too much power going into that. I gotta find the manual to this thing. Hang on a second. Let's go to documents. Sorry, I apologize. Hard disk drive. No. So did I not download that? Or I must have downloaded it and not put it anywhere? Oh yeah. It's in my downloads folder. So this is a Kessler Oracle controller MC1004. 12 volts DC. So it definitely runs on 12 volts. So yeah, 100 input, 1.4 volts. Yeah, so it's definitely got the input volt. Oh, here we go. Here's the power brick. I got the power brick here. Output 12 volt DC, 1.5 amps. So that's, yeah, so I've got it set correctly. I've got my power supply set at 12 volts, 1.4 amps. I'm going to push that diode out of the way again and see if that's the reason why this thing wasn't turning off. I hear a weird noise coming from this though. It sounds kind of weird. Let's go to scope cam. Bring the scope back here. We're going to kind of bend this diode out of the way just a little bit. Make sure the power's off. Yep, power's off because we don't want to be feeding voltage through this. Okay, so I'm going to try to power it on. Nope. It's still turning on. I'm hearing some weird noise coming out of this thing though. I think it's that I still think that MOSFET is croaked. It's this, I think this MOSFET right here is making that noise. Yeah. We'll put some alcohol on it. Let me see if I can focus up here. I think that MOSFET's bad. It's making a weird... I'll see if I can get close after I do this. It's making like a weird hissing sound. Yeah, that MOSFET is toast. Look at that. Yeah, I don't think it should be doing that. God, that is very ominous sounding. It's scary. Watch, I'll put my microphone up to it. And you can smell it. It does not sound good at all. It's drawing the full... Oh wait. Yeah. Let's see. Probably had my current up a little high, but I think that, yeah, that MOSFET, look at it. 250 degrees that thing was. And this is not turning on anymore. 234 degrees. So yeah, that MOSFET is cooked. So we're going to replace it. I think I was putting extra current through it. That's why it was turning on. Because I was putting extra current through this. Oof, that thing is still freaking hot. Oof. I think I was putting extra current through it. That's why it was actually turning on. Anyway, we unplugged it. We're going to go ahead and desolder that MOSFET. And we'll check it for shorts. So, which I'm sure it's guaranteed to be dead. I got a blowhole in it or anything? Nope. I don't see anything. But it's definitely mad. Definitely mad at the world. Is it cooled off yet? Still 144. Yeah. That MOSFET's had it. Alright, let's desolder that sucker. We'll desolder it and we'll test it. Sorry, I'll go to microscope cam. Sorry, I know this is a bit frazzled, but this is kind of a bit experimental on my part. I don't know a lot about these controllers, but I definitely know how to look for a shorted component, and so when you supply enough current, it does turn on. But that MOSFET, it's probably doing some like bridging the connections or something. So hopefully it'll operate correctly once we fix this. This would probably help if I got my fume extractor a little closer. You know what? I'm gonna move the camera because this will move the microscope. It'll make it so much easier to do this without that in the way. Yeah. Hot. Well, I'll use a little tiny bit of low melt, make this easy on myself. And it's okay to use low melt in this instance. You just make sure you clean it all off as much as you can when you're done, and it should be fine. Make sure to get that off the board. Oh yeah, see, this stuff makes life so much easier. Boom. Dropped out. And now we're gonna soak up all that and get rid of all that low melt, so the new MOSFET will sit in there nice and tight. And very nice, very nice. All right. I think we'll probably replace that. We'll probably replace that diode too, just because I don't like that leg busted. We're not gonna go through all the trouble of fixing this and then leave that busted diode in there. We'll fit a nice new one in there. So, MOSFET in question is a Fairchild Semiconductor E44H11. Pardon me while I look for the data, the data sheet. So, yeah, KSC 44H series. So it's a general purpose power switching MOSFET. Or transistor, not a MOSFET, a transistor. So base collector emitter, yep. So yeah. So even though that's getting hot, that may not even be the problem. It may be something else. So we're gonna test for shorts. The cool thing is we have two channels. It seems like on this we have two identical setups here. So we're gonna do some diode readings here. Gotta find a ground plane first. This ground here. That's ground. So we have a short there. So we have a short on the emitter. The emitter pin. Now why is that? So what is the resistance? Yeah, we have a dead short on the emitter pin. Should we have a dead short there? Let's see. I'm gonna measure the emitter pin on this other MOSFET. Sorry, can you even see what I'm doing? So over here it goes base collector emitter. We have a short here. So hopefully this chip isn't dead. Or something else. But I'm going to test the resistance between ground and... So between ground and that pin I'm getting 0 ohms, so that's shorted. I'm trying to see if... So that might supposed to be what it is. Because I'm showing short. Or 0 ohms on that the other pin, the other MOSFET, or the other transistor. So I think I'm going to, I bought a bunch of those transistors, so I'm going to solder another one in and see what happens if this one gets hot as well, or if that gets hot too, then it's probably indicative of something else being wrong with this board, and so we'd have to troubleshoot further. Some resistors there. Yeah, so I'm not sure if something else is causing this to heat up. We're going to solder a new one on and find out. I'm not overly familiar with this circuit, so let's see. I'd have to trace the board and figure out so that I see where that emitter, where the signal for the emitter is coming from. I don't see anything else burnt on the board, so I should probably try to figure out more on how all this works. I cannot see. Can you see what I'm doing? Just soldering these pins here. I mean, that transistor is making an awful sound. Oh. Fume extractor. Give myself a headache. Gently clip the legs on this and clean that up. My clippers are pretty messed up. Alright, let's see if it still makes that noise. If it is, we'll have to troubleshoot further. It should turn on now. If this is fixed, it shouldn't be making that crazy noise. Also need to fix that diode too. What if I will replace this diode, but I think I'm going to throw some solder on here to bridge that leg. If I can. Nope. Doesn't look like I'm able to. Let's just replace it. Okay, stripe goes that way. We're just going to replace it. Why not? If you're going to do it, then do it. Where was that leg sticking out? Was it this? Yep. That's our little diode leg. Our little busted diode leg. Should be the other side. Oddly enough, it is going to our transistor. Is it not? Where's our transistor we just soldered? No, a transistor we just soldered's here. Yeah. Yep. This leg of the diode goes over here to our collector of our transistor. So we definitely need to get rid of him. I have to poke my tweezers. Get this guy to go. There you go, buddy. On to greener pastures, guy. Ooh, he's stubborn. Stubborn little diode. It's like I could still do my job. Let me stay. Let me stay. Oh, I'm sorry, buddy. You gotta go. You are out of here, buddy. Or wait, am I doing the right? I'm not desoldering the right thing. Dummy. It's this. Yeah. That needs to be resoldered. That's my coil. I gotta leave that soldered in there, Nimmy. Ow. That's one way you can tell you're doing the right component. It gets hot. Use low melt on that again too. This is being way too difficult. There we go. I know you're still good, but all right. Enough goofing around there. get all that flux off there. Alright, let's try that. Let's try a new diode in there. Is there IN 5822? IN 5822. Sorry, turn the fume extractor on again. These fumes. See how we're looking in our placement. Good enough, I'd say. It's all cleaned up here. Get all the flux off. Alright. Let's see if that worked. If not, we'll have to continue our troubleshooting saga. because we really want this to work. Oh, got some flux on the top side here. Boom. Fixed. Look at that. We're at 12 volts, 100 milliamps. Look at that. There's our diode. So what does this say? Head unit to slider. Look at that. It's got like automatic I'm gonna turn the light off. Watch, it's got backlit. The backlit screen. I don't know how to use this thing, so look at that. We've got inputs. Yay, we fixed it. Ha, it was that blown transistor. Let's do the thermal camera and see. So see, I didn't know exactly how this circuit functions, but I know that that transistor was getting super hot, and they should not, for what they're doing on this board, they should not be getting that hot. So it was a blown Fairchild general purpose power transistor. But it's working. Look at that. Yeah. Nice and quiet. Any overly hot components? That guy's getting a little hot. He's 105, but like right here, right there is our, so right here is our new transistor. Not getting hot, but we replaced that diode and that transistor. So that, I don't know if that's concerning or not, but this has got a giant heat sink here too. It's this part here, which we'll look that up real quick. I don't know if that's supposed to be getting that hot. What is that? Let's see. Scope cam. 7805. That's a 5-volt regulator. Yeah, 7805 BD2T. That is a 5-volt regulator. Guarantee you, I'll look it up on semi. Let's Google that. 7805 BD2T. BD2T. I bet you that's a 5-volt regulator from onsemi. Yep. It's an LM7805 5-volt regulator. They sell those at Mouser? Maybe. Might have to get some of those. Yeah, it's a 1 amp positive voltage regulator. That is a DPAC 3. or yeah, or D squared pack 3. So D2T suffix. Yeah, so that's a D pack. I'm gonna save this data sheet. Optimize. Let's see. On semi. Anyway, yeah. So yeah, that is a fix. Blown transistor. Now all we have to do is talk to the customer and see if they want us to repair their charger, because as you can see on the end of this, there is no jack. That's not good. So yeah. Anyway, it's working, fixed. Awesome. I think we'll put it in the we'll put it back in the box, and then we'll give it a full we'll go whole hog on it and give it the full test, and I'll hook it up to the crane arm and play with it and see how she works. Anyway, thanks for watching this video. If you liked it and you need something repaired, go to support at Optimized Logic Repair. Drop us an email and let us know if you have a device that needs to be fixed. Anyway, thanks for watching this video. Have a good night.